Okay, so welcome back once again. This time we're doing the dx of tan x using the first principle. So here is the definition that we have here. So like we did in the previous video, we're just going to do the same. From what I've observed is under this topic, differentiation using the first principle, it's all algebra. There's no calculus in here. So if you understand the basic principles of algebra, then this is an easy thing. Now, for your information, the previous video had a method that we used when we were solving it, and in this case, this other one is also going to have something new. So don't feel this one has less data, like the channel is saying higher data video. So you have a lot to learn from this one. So let's dig in. Okay. So we're going to do the same thing we did in the previous video. We've got the function tan x, so we're going to replace wherever there's x in this function with this function f of x plus h minus the original function, which is tan x, divided by h. So here we go. So we're saying the limit as h approaches 0 is equal to tan x plus h minus tan x over h. So we know that tan x is equal to sine x over cos x. So we're going to replace that with that which we have here. So we're going to say the limit as h approaches 0 is equal to, so here we have sine x plus h over cos x plus h minus sine x over cos x. This is all divided by h. Now, just like I was saying, this is all basic algebra. So the same, we're going to apply the method that we're using when we're looking at partial fractions. We're going to resolve this function. We're going to make it one. These two functions are going to make it one function. So it's going to be sine x plus h. So we have a common denominator here, which is cos x plus h cos x. So when we divide this into this denominator, we have cos x minus cos x into this one, we have sine x, multiply it with cos x plus h. So saying limit as h approaches 0. Wow, so this is a very beautiful equation you can see here. So hope you can see what I'm seeing here. Can you see it? So for me, what I'm seeing here is this function. I mean this identity under trigonometry. We had this identity, which is saying sine a minus b is equal to something. So that something is what we have here. If you can see it clearly, remember in the previous video we had plus here, but we have sine. Now look at this carefully. We're saying let me just write this function here, the identity for this one here, so that you can see, you compare with what is here. Yeah, so this is what I was saying. Sine a minus b is equal to sine a cos b, sine b cos a. Now look at this one. We have sine x plus h cos x minus sin x cos x plus h. So in this case, this is our what? This is our a, x is what? Our b. To prove that x is our b, look at what is here. Sin x is our b, cos x plus h is what? Our a. So we're going to replace wherever there's x in this function with just a and b. So this is what we'll have here. Okay, so look at this one. They're saying sin a minus b is what will give us this. So what we'll do here is we're going to replace sin a. A will be this and b will be that. So here is how it's going to be. Sin x plus h minus what? Minus b, which is x, over cos x plus h cos x. Now we forgot to include the denominator there, which was h. So we can deal with this denominator here by saying 1 over h. So the denominator is going to multiply with the other denominator here. So what we have here is, in the brackets we have x plus h minus x, meaning that this is all going to be equal to sin h, because x and x will cancel. So we'll have the denominator is going to be cos x plus h cos x. So now we're going to apply the limit to this function. We're going to say limit as h approaches 0. This is going to be remember that other identity that we had looked at yesterday in the previous video was saying if the limit h approaches 0 for sin h over h, this is equal to what? 1. So this is what we'll come up with here again. So we'll have 1 over, so we're going to split this 1 over cos x plus h cos x multiplied with the sin h over h. This h here is what has multiplied with the denominator here. So we're multiplying everything in the denominator and multiplying everything in the numerator. So we know that this is what? This is 1. So 1 times everything that is here is just going to give us this. Now, since we've applied the limit here, if we replace 0 in this function here, what are we going to have? We're just going to have cos x multiplied with cos x again. Now you're familiar with this function here that we have here. This is what? 1 over cos squared. Now what is cos squared? This is an inverse trig function which is equal to sec squared x. So we've now we found the derivative of tan x that we had there is what has given us sec squared. So this is it. Again, don't forget to like the video, share it with your friends if you like it, and don't forget to comment about the next video that you want us to do. See you. Have a blessed day.